Welcome back to our recorded sessions of science. In the last video, ma'am has explained to you the various elements of a circuit. Now let's discuss what happens when electric current passes through the appliances. Or we can say, what are the effects of electric current? Okay children, so let's move on. So here, you all know what is electric current. Electric current is the flow of charges or flow of electrons, right? We have done this and we have done how the circuits are made, how the path of electric current is made. Now, a second point comes is its effects. What are the effects of electric current? So, I am going to do the heating effect of electric current. Now, what do you mean by heating effect? Like you iron your clothes, isn't it? We use an iron. What happens when you put in the plug? The iron gets hot, right? That is called heating effect. We have toasters, right? You have ovens at home. Your mother is baking a cake for you. We have immersion rods. All these things are making use of electric current. And ultimately, what are they actually producing? They are producing heat energy, right? So, if there is no electricity, your iron will not become hot. If there is no electricity, your microwave will not work and your mother will not be able to bake a cake for you. If there is no electricity, your geyser will not work and you will not be able to get hot water during the winters. So that is the effect of electric current, that it can produce heat energy. Now let us discuss this in detail. So some points you need to remember. Point number 1, when electric current passes through the filament. Now what do you mean by filament? Just go back to your class 6. You remember we did the electric bulb, and in that electric bulb we have a coiled wire. You remember this coiled wire? We call this coiled wire as filament, right? So what happens? When electric current will pass through this filament, what happens? This filament becomes red hot and it produces heat energy and light energy, right? You remember, or you must have seen at home, when you stand near a bulb or if you place your hand near a table lamp, what happens? You can feel the heat, and because of light you are able to see things around you. So what is the electric current doing? Electric current is producing heat energy and light energy, right? Now the question comes that how is this heat energy or light energy produced? So let's keep in mind the connecting wire. You remember the connecting wire that we have done in our previous class? Connecting wire means the wire which will carry electric current through it. So here I have my connecting wire. You know how we make a connecting wire? We make a thick line and we show the connecting wire. Now through this connecting wire, what is passing? Electric current is passing, right? Now when the electric current is passing, that means what is actually moving? Electrons. Electrons are moving. Now in our previous class, we have discussed that when something is moving, when there is a contact force, there comes another force that is called force of friction. Yes or no? What is this? When I rub my hands, what is happening? After some times, my speed becomes slow. Yes? Because when I am rubbing my palms, friction is produced. And when friction is produced, what happens? Heat is produced. Right? So this is my connecting wire, this is my copper wire, and through it the electric current is passing. So when these electrons are going to rub against this surface, what will happen? Friction will be produced. And what is friction? Resistance. You remember we have done resistance or a resistor. Resistance means to oppose. Current is flowing in this direction. Friction will be in this direction. So ultimately there is friction. And when there is friction, heat is reduced. So you understood how heat is produced? Now my next topic is which materials will produce. So now there are some materials which offer less resistance, while there are some which will offer more resistance. For example, if you consider a copper wire, the wirings that we have in our appliances, through them the electric current is passing. But in this case, the friction is less. When the friction is less, that means less heat is produced. So when you touch the insulated copper wire, you cannot feel the heat. But what about the filament, the element? It becomes red hot. That means it is made up of some other material that will offer more resistance or more friction. So here you need to remember 2 points. When there is less resistance, then no heat will be produced or very less heat will be produced. So in case of copper wire, it will offer less resistance, less friction. So less heat is produced, or you can say no heat is produced, right? In case of nichrome, we have discussed in our previous class what is nichrome. Nichrome is an alloy. So if I talk about nichrome, and you know that nichrome is used as a resisting wire. That means it opposes the flow of electric current. So when it will oppose the flow of electric current, what will happen? More friction. More friction means more heat. So the heating element in your geyser is made up of what? Nichrome. And that causes the heating effect. That is how your water gets hot. Right? Same is the case with your iron. The iron that you use. In iron, the wires are made up of copper. So they do not get very hot. But the heating element that is made up of tungsten or nichrome, that becomes very hot and we can use that heat to iron our clothes. Now let's talk about the bulb that we did in class 6. Now in this bulb again you can see that the filament is in the form of a coiled wire. Here it is which material? Tungsten. Again, tungsten will offer a huge amount of resistance. That is why it produces yellow light. Yes, yellow light it is producing. Lot of friction is there, lot of resistance. And lot of resistance means lot of heat is reduced. Now, because of so much heat, this bulb can blast. It can burn. But why doesn't it burn? That means something else is also being used. We use argon gas. Okay, now children, what is argon? It is a gas like carbon dioxide is there, oxygen is there. Similarly, argon. But it is a very, very inert gas. Inert means it is not reactive. It will not react. So what happens? This argon will keep a control on the heating effect of tungsten and this tungsten will not burn. Okay children? Now, that is how heat energy is produced and light energy is produced. So you need to remember that in case of this electric bulb, a large amount of electric energy is being used. And it is changing into which form? Heat energy. I think you must have noticed when we go for weddings and all, you must have seen the halogens. If you stand near them, you can feel the heat. Yes? So a lot amount of electric current, electric energy is wasted in the form of heat because more and more of resistance is there. But nowadays there is an alternative. we use CFL, isn't it? We use CFL bulbs, tube lights at home. They are energy efficient. They have the element which will not heat a lot, right? So it produces white light. So the heating effect is less and we get white light. So though they are very expensive, they cost you a lot, but in terms of electricity usage, they are very, very useful. That is why we call them energy efficient. Right? So children, I hope you must have understood. It is the heating effect of electric current that you are able to use a toaster, a microwave, your iron, your geysers, your heaters at home. See you next time. God bless you.